Hello everyone. In this video, I will be discussing on 8085 programming examples and how to develop an 8085 program. I will be having an overview of only two programs and hope these two programs will give you a lot of scope on how to write a program in 8085. Let's start our video with just by giving an outline of what a program consists of, what the program consists of, and how to develop an 8085 program. So this lecture will be helping a student to gain knowledge in 8085 programming. This would be my objective, and let's start with a kickstart with a program of how to add a number, just addition of number, and it's just like a full adder. A full adder is what, and a half adder is what. A full adder will take into consideration of carry, and half adder doesn't take into consideration of carry. The same thing over here. This program is been written for including a carry. How to develop a program? Now, how the program will runs out by taking into consideration the carry. First of all, we need to have a small overview of some of the instructions of like data transfer instructions, some of the instructions of arithmetic, some of the jump instructions, all these instructions, I mean to say branch, control, transfer instructions, all these instructions, you need to have a few of those collection. Then putting on all this one in a beautiful manner will generate a very wonderful program. And believe it, when you have a little bit of concept about the instructions and checking out the manual, and you can generate any program just by visualizing what will happen at each step. Let's say when you go for addition, I'm not discussing about the program. I will leave it this one as a blank. Okay. I will go for the blank one. I don't go on with an with this line. I will just go with an blank. Let's take this one. Now addition is what? Addition includes addition of two numbers. Okay. So here, if I want to go for addition of 2 and 3, it's a simple over here. 2 plus 3, you will be getting what? 5. Addition of 2 and 3. That's it. So simple, you will be getting as what? Answer is equal to what? 5. 2 plus 3, you will be getting as what? 5. This is one addition over here. Simple addition. Then we'll go for a little bit of that. 2 plus 3. 2 plus 5. 2 plus 9. Now 2 plus 9, what it does is that it will get you addition for decimal addition. The result is what? 1. And there is a carry 1. Now this is not a complete result. For this reason, what we'll do is that we'll take the tens place also and we'll save it. The same thing applies to the addition of hexadecimal. Here for a decimal, we'll be doing the addition till 9. When you go for hexadecimal, it would be till F. After F, you will be doing as what? So here, when you go for this one, this is 8-bit. And remember, when you go for now, when you add two 8-bit numbers, the result may be extended to 9 bits. There may be a carry. So in that way, let's say 2-digit number is there. Simple 2-digit number of a decimal number will consider. Then we'll go ahead with the next one. So if you are going to add 50 plus 60, the result is what? 110. But as the tens place, you can display only 10. You can display what? Only 10. Then this one, 110, this one should be what? This is not displayed. So to display this one, we'll have an additional one. That is nothing but the we can say carry or the additional one has to be there. So the same thing over here, it is been shown in this program. Let's start with this program. What I will do is that I will have you had two numbers in the memory location. This is the one prototype of the program. The same can be developed for all the programs in this. So here 8085 is been gifted with some of the instructions which are truly simple to use and straightforward. You can refer to the memory location and bring it to the active mode. The instruction is LDA. That is wonderful. And next one, I'm using the additional higher order bit. I'm going to say the lower order bit would be there in the lower order 8 bits would be in the A register, higher order bits would be there in the B register. The result would be, my aim would be what? Addition of two numbers. Such a way that when you add these two numbers, the result of the addition would be such a way that the lower 8 bits would be in A, higher 8 bits would be in C. So to add this one, what I'm doing is that I'm initializing C register as 0 and loading the A with the first value. The value which is to be added from the memory location, I'm loading into the A. Then I'm moving this value into the B register for further reference. I mean to say, I'm going to add the two registers A and B. The value which have been loaded from A, I'm transferring into B. Then loading the next value into the A. This, why I'm using this instruction? This is because I had an simplicity of using of LDA instruction. When you are using LDA instruction, directly the value will fall into the A. There is a simple task for it. That's the reason I will be going for LDA, giving a memory location value. Automatically, the value will be loaded into the A register. Then LDA, next value will be loaded. So now the loading of values into registers A and B has been completed. Till this point, it has been completed. So the next instruction is what? Add B. When I give add B, immediately the A content and B content are added and the result is stored in A. And automatically, upon the result, I carry flag is been sent. A carry flag would be 0 or carry flag would be 1, depending on the result. If the carry is generated by the addition of these two numbers, carry flag will be 1. So we will be checking a condition whether a carry is in there or not. So here what I will do is that I will just have a simple instruction of jump if no carry. If carry is not there, then C value I won't increment or it doesn't want to increment hundreds place. As for the decimal addition, if you say hundreds location, it doesn't want. If a carry is generated, then the same thing is that jump if no carry. If a carry is not generated, doesn't need to increment the C. If carry is generated, increment C and then store the result into the memory location. Otherwise, whatever the value is there in C, A, you store it in this. And with speaking with this LDA instruction and STA instructions are two gifted instructions for the accumulator, dedicated for accumulator. Those instructions you can fully utilize in the programming. So here, loading a value so whatever the A value is there, we are storing back into the present. Now, if at all the carry is there, the C would be incremented. If carry is not there, C would be 0. So whatever the result is there of C, that has to be saved into the memory. So C value is being taken into the A, and from the A we are storing into the memory location directly. So this is one of the simple program for addition. Now directly straightforward, we'll go for moving to a program on a very complex program. We'll see that is nothing but let's take instruction. You mean to say the program used for sending order program. See here, mugging these lines and all those things is not one. Just imagine what is the program and how to develop the code for that. The program is such a way that sorting of a number. we'll be going for taking one number and comparing with the second one. First number is compared with the second one. Second number is compared with the third one. Like that way, we'll proceed it. And once we get the largest of a number, we'll stop the update. Then we'll fix up the largest at the bottom. Then next largest will sit into the next second bottom. Like that way, we will proceed setting up the bits, and the last one you'll be hitting the. And to have this one, once we set up the first largest, one set of comparisons have been completed. Then what we'll do is that we'll decrement the value. Then again, out of the four, first out of the, let's say I had five numbers. Out of the five numbers, four numbers have been saved. Then out of the five, largest of five, I have got it. Then left out for four. Out of the four, next largest I will find it. It is out of the four, whichever the largest is there, I will find it out. That would be the second largest number out of the five. Then left out three are there. In that one, I will find out which is the largest. Then this would be the third largest number out of the five. Then out of the two, whichever the largest is there, that would be taking the second position, and the first position is given the smallest number. So here the numbers are arranged in such a way that the first is the smallest, then second is the second number to say somewhat larger than the smallest number. Then it will proceed to the largest number. This is an ascending order. To do this one, for every process, for finding out one largest number, we need one comparisons. And one more thing we need to look at what this. How many counts or how many times we need to go compare. We use a very important instruction over here in this one is compare. So how many times we are going to compare? We are going to compare if at all five numbers and then we are going to compare four. How many? Four. And if at all, if it's six numbers are there, we'll go for five combinations. Like that way, when you go for finding one largest number, it will be set at the bottom, second largest at second bottom, like that it will proceed. So the same thing has been written in this program. Now, LXI H comma 420, this is the memory location where the numbers are stored. Actually, the first the count value would be there. I have moved the count value into the C and decremented the count because five numbers are there. I need to go for what? Less than one count should be there. The same value I'm going into the D. These two registers are used for and next one, take this value into the memory location A and compare, jump if carry, move this lot of instructions are there. So simple instructions, moving a value, if a carry is there, like that way, this process will be better understand when you are doing the programming. Obviously, once again, we'll discuss this program. But as for this one, so how to develop a program is that first, learn the algorithm, learn the basic steps. What is a program is meant for? Then you can develop a program very simply. Obviously, only when you see all these instructions, same instructions would be there. Move instructions, decrement, increment, LXI, LDA, not complex instructions. Those instructions will be used and how you frame those instructions. So this video, I hope you got at least some concept about how to develop a programming. Obviously, you can gain very much good knowledge when you are going for programming in Regimental Laboratory. Thank you for watching this video.